Okay, that was in a general situation when you're given the equation. And by the general situation, I mean you had an h equals, like a physics equation, h equals negative 4.9 t squared. And we can do it in those situations as well. But the other interpretation of this is not that we're looking for the instantaneous rate of change, is that we're looking for the slope of the tangent. Those two things are exactly the same. And the procedure is exactly the same. But the pictures in your notes are not too good unless you really have seen this before. So I really want to walk through those pictures. They've shown a picture here which they think is wonderful of showing off what's going on here. But I'm going to give you some better pictures. Well, they're not going to be better quality. They're going to be handwritten, but they'll be like, oh, I see what's going on here. So the question they're asking is, for y equals x squared with the point 1, 1, try and find the slope of the tangent. So what they really want here, and here's a quick drawing of y equals x squared. I'll just draw it like that. More loopy. I need it to be more loopy, like that, yeah? And they want, at the point 1, 1, right about there, they want the slope of this tangent I've been talking about. Just move down a little bit. Second, let me do it. Yeah, 1, 1. Okay, so they want this slope of this tangent. That line that just meets it at exactly 1 point there. That's what they're after. Here's the plan. Find another point that's close to it, up here somewhere. And find the slope of the, I'm going to draw it in red. This is what we don't want. We don't want to find the slope of the secant. Oops, I said red, didn't I? Red. And this is the greatest picture of the whole section here. This is a secant. We're going to find the slope of a secant. And apparently, that's going to be a pretty good estimate of the slope of the tangent. No, it's not. Look at how much different it is. Huh? But that's only because I was far away. So take a look. Here's the whole table that they did there. The initial point was 1, 1. Then they went out and found a second point out here, and they decided to use an x value of 2. Why would you go 1 away? Well, you wouldn't, unless you were teaching this stuff and trying to show somebody what the plan is. Now, they got an x value of 2, and then they got a y value of 4. Where did they get the y value of 4 from? Well, they used the equation. The equation y equals x squared. Remember all that subbing we did? We subbed into h every time? Here, you're just subbing into a nice simple y equals x squared equation and getting the point 2, 4. That was their first estimate. So then they went delta y, then they went delta x and found the slope. And the slope of this secant was 3. Was it a good estimate? I don't really know. We got to move closer. So then they got a closer point. They came in closer here and they said, well, 2, 4 was too far away. So they used the point at x value 1.5. And if you've got 90 more seconds of full attention span, here it is. If I get this 90 seconds into your brain, you're like, I totally get it. Then they drew a new secant. And all you got to know about this new secant, do you see how its slope is heading towards the slope of the tangent? It's a better estimate. See, the slope of this one, this first secant, wasn't even close to the tangent. But as I get closer, do you see it's now closer? It's a better estimate. Now, big moment. This is the moment if you're going to text me with questions about this, this is what you're going to ask me. You're going to choose your x value of 1.5. How do you get the y value? Yeah, you just square it. You just put it in the equation. So to get y values, you're always subbing it back in. That's going to be true in everything we do now. Oh, how do I get the y value? The equation's right there going, I'll get you y values. I mean, that's what it does. It says, here, you give me an x value, I'll give you a y value. So you punch that in and you get 2.25. Whoops. And so they got their new point. Found delta y, found delta x, found slope 2.5. It was better. Is it a good answer? Well, we don't know. We got to get closer. So we get a little closer. 1.1. Answer 2.1. 1.01. Answer 2.1. All that is subbing in and finding slopes. Now that you can look at the table and see everything I've done, can you look at that column and say, I think I know what the answer is? Yeah? Our first estimate was 3. Oops. Our second estimate was 2.5. Then we got a better estimate of 2.1. Then it's 2.01. Are you willing to go out on a limb here and guess what you think the slope actually is at x equals 1? It looks like it's heading towards 2. Okay? So There's questions like this in the homework. Virtually identical, just a different equation, different x values, and you just got to make the table. It's called method 1. Method 2 you won't learn until you get back next week. It's actually, we always teach that in 2 separate days. You really got to practice this once before and get the logistics figured out, and then I'll show you a different method of doing it. The second method's tougher to understand, but doesn't take as long, right? And it has advantages and disadvantages. If that only sort of came at you, here they did it from the left side. Because some people might say, well, how do I really know what's going to settle in? Shouldn't I come in from the left as well? I don't get too carried away with that. We take care of that in calculus. But we really should come in from the left side as well. So instead of using numbers that were bigger than 1, this table uses numbers that were smaller than 1 and does the same thing. Again, how are they getting the y values here every single time? They're just using y equals x squared. Then they do delta y over delta x, and look what it does from the other side. Our guess was, look, we thought it was 2. Someone else does the question, and it comes from below, and they go 1, 1.5, 1.9, 1.99. What are they going to say they think the slope is? 2. So it works. It really does trap the slope in there, whether you come from one side or whether you come from the other. So the key idea is the slope of the tangent is the limiting values of the slope of the secants. And I don't think I've used the red highlighter once in this course, and I've used it 6 times today. How do we find slope of tangents? We find slope of secants that are closer and closer and closer until we feel great that we've got the slope of the tangent. The rest of the lesson is just me redoing that Earth thing with graphs. The idea that as you zoom in, the Earth is flat. Don't go home tonight and say, Mr. Todd said the Earth is flat. It is kind of, like you zoom in far enough, you lose all the curvature of it, and you can estimate it by saying flat. So here's the zooms. Here's some random function I've got here, and I put a tangent line in there. And now I got a computer to draw the tangent. Computers know how to draw tangents, so I made it draw the tangent line at a particular point. And then I put a secant on. So just label that diagram if you've got it in front of you. There's a secant and a tangent. And do you agree the slope of the secant and the slope of the tangent are completely far away from each other? That's on the second diagram, I think. If you flip the page, now you can find a secant and a tangent. The secant sort of goes straight up, and the tangent sort of goes off to the side like there. And then I'll say my line again. We're going to use slopes of secants to estimate the slope of the tangent. And when you see this diagram, you're like, no, you're not. That's awful. That secant and tangent isn't anywhere close to each other. So I'm going to zoom in a little bit. And I use the computer to zoom in. Now if I zoom in a little bit, there's the secant. And there's the tangent. And you're still like, that's horrifying. That's not even close to a good estimate. How are we actually going to build a world, iPhones, airplanes, how are we going to do anything and build anything in the world if this is your kind of estimates that you're going to do? And I go, okay, zoom a little closer. Do you see what's happening as we zoom in? Secant and tangent, they're pretty close now. Maybe this is a good enough answer. No, just keep zooming. And you can label them on every single page if you want, or you can just go, oh, I get the idea here. If you zoom in far enough, if you get close enough, just like the planet Earth, if you zoom in far enough, you won't really be able to tell anymore that we were talking about something that was really curving. We've zoomed in far enough that the secant, the tangent, and the curve are so close to each other we can't tell the difference. It's like 2.01 and 2. We now know it's like really close. That's just saying the same things I just said out loud. Label this in your notes, please. This is where we'll pick it up on the Monday you get back. This is called Method 2. And I'll talk more about Method 2 when you get back. So I modified the homework because of that. Do you have any questions about the big idea here, though? My goal sort of is the first explanation on a scale of 1 to 100 understanding this. If I can get you to a 50, where you go, I sort of get what you're doing here. That's maybe the best I can do without you doing some homework first. Then you do the homework, and you come back and you go, well, what about this? What about this? And you refine the details.